Hello and welcome to yet another video of Cornerstones of Math. In this video, I am going to solve two integral problems. As for the first one, well, it has a lot of arctangent functions, which is the inverse of tangent and also commonly written like this. The second one is the integral of the product of three functions, x times e to the power of x squared times sine of x squared. Alright, starting from the first one. The key here is to remember that the derivative of the arctangent function is 1 over 1 plus x squared. You may have done the reverse process many times using the trigonometric substitution. Therefore, if we use the substitution, arctangent x equals t, then since 1 over 1 plus x squared dx equals dt, this part becomes dt. So the integral becomes arctangent x, so t, then arctangent of arctangent x, so arctangent t, then this dt. Now some of you might remember applying integration by parts when you have the product of an algebraic function and a trigonometric function. So let's try that method here as well. The thing is, we know the derivative of this arctangent function, so this function must be differentiated. Therefore, we let u as arctangent t and v prime as t. Then u prime equals 1 over 1 plus t squared and v equals 1/2 times t squared. Then we have uv, so 1/2 t squared arctangent t minus integral of u prime v, which gives 1/2 times the integral of t squared over 1 plus t squared dt. As for this part, we split this into 1 minus 1 over 1 plus t squared. So we have this minus 1 over 2 times t plus 1 over 2 times the integral of this. And hey, this one looks familiar, right? This is the integral that gives arctangent function, which you can easily verify by using trigonometric substitution. So we have this plus constant c, and let's write this as 1/2 times t squared plus 1 times arctangent t minus 1/2 times t plus c. So changing back to x, we have 1/2 times arctangent x squared plus 1 times arctangent x minus 1/2 arctangent x plus c. And the second one, and for this one, the substitution is even more obvious. We have x squared at the exponent and inside the sine function, and we have x here. Therefore, we let x squared as t. Then 2x dx equals dt. So if we let I be the given integral, we have integral of e to the power of t sine t, and the remaining x times dx gives 1/2 times dt. Let's apply integration by parts with u equals sine t and v prime equals e to the power of t. Then u prime equals cosine t and v equals e to the power of t. So we have 1/2 times uv, so e to the power of t sine t minus integral of u prime v, which is e to the power of t times cosine t. This time, let u be the cosine t and v prime be e to the power of t. Then u prime equals minus sine t and v equals e to the power of t. So this time we have first uv, so e to the power of t cosine t, Then, because of the minus sign at the front, we have plus integral of u prime v, which is e to the power of t times minus sine t dt. Therefore, we have 1/2 times e to the power of t times sine t minus cosine t, then minus 1/2 times integral of e to the power of t sine t. Here, notice that this part is the original integral I. We have to include this 1/2 as well. Be careful with that. So we have I equals this minus I. Therefore, the original integral I is given as 1/4 times e to the power of t times sine t minus cosine t. And we have to add constant c. And since t equals x squared, we have 1/4 times e to the power of x squared times sine x squared minus cosine x squared plus c. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.